So, hello everyone. My name is Matheus, and I'm a software engineer here at TRV in Prague, doing front-end stuff. And today I'm here to talk to you about a few thoughts I have on the future of React.js. And this is supposed to be the full length of this talk. There's a shorter version online available as well. But before I start, I have to share a few goals that I have with you today. And if I stop to see what's been happening on React since React 16.3, we see that there's a bunch of cool stuff happening in such a short period of time. And there's all of those crazy and good things that are happening kind of reminds me of this quote by Guillermo Roche from back 2014, where he said that React is such a good idea that we will spend the rest of the decade continuing to explore its implications and applications. So, based on this, I want to first present a few thoughts on DOM, scheduling, and control flow of your code. And then I want to prove three theories I have regarding the web platform as a whole and React.js itself. But I can't provide any spoilers here for now. And also a few disclaimers. The first one is that the source code is not an easy to read thing and it changes a lot. And the second one is that given this, some thoughts here are speculative and also because it's talking about future, anyways. But and the third one is that whenever you see this, it means that the whole topic is kind of complex and that you can reach me out after this case on Twitter for that so that we can discuss more. So first, Don, I wonder if many of you have heard about ReactFlight before, but for those who haven't, basically it consists of an effort from the core team to modernize the React DOM package. And basically it's focused on making the whole React thing better aligned with how the DOM works nowadays. And it also aims to make React smaller and faster. And it brings a bunch of changes, including, for example, attaches events at the React hook rather than the document. It migrates a few APIs like onChange to onInput so that they can be more consistent to the naming that we have on the web. And also, they stop polyfilling it, for example, for uncontrolled components. Migrate class names to classes, and you have what they call text flare, amongst many other things. So ReactFlare is what I consider most exciting about the whole ReactFire thing. And basically, it's their API for events. So it's also called React Events. And it all started with Nicholas, who is the creator of React Native Web, and which kind of makes sense because he's the one who is supposed to care a lot about cross-platform consistency. And basically, it's the whole event system under umbrella under React So it aims to make easy to build UIs that feel great on all the platform with all kinds of events, mouse and touch, and makes it then also accessible. It includes some declarative APIs for managing interactions, which we will see in a moment. And unlike the current React event system, the Flare design doesn't inflate the bundle for events that you don't use. So that's, for example, one of the reasons that you have smaller bundles. And it should allow to cut down the amount of code in UI libraries that deal with mouse and touch events. So those declarative APIs are mostly hooks, and examples are use tab, use keyboard, use press, use responder, use focus manager, some listeners as props, and for example, the use keyboard hook would look like this, and you could have some config parameter. And in this config, for example, you could prevent a user from tapping some keys by passing those keys metadata. And another example of hook that Flare would bring is this use focus manager where you just pass some unchanged handler and then it returns you unblur and unfocused events. And those events could then be used as props in regular elements or components, etc. But the bad part is that the whole Flare event system ended up being a too high level abstraction. So as parts of the event system work that they consider unnecessary or outdated were removed, they somehow figured out that actually they were being helpful in preventing bugs. And actually, they found out that it was not the best trade off because they removed some library code that ended up being re added in application code. And even basic things became too complicated. So back in December, this was like the closing discussion from Nicholas. So they concluded all of this that I just mentioned. But the good thing is that they made this, I mean, they worked on Flare and Fire for like almost a year. So they made very good progress and they made very important discoveries. So they will be exploring other ways of modernizing the whole down part in React in the future. And as lessons learned, I would say that this shows us that React.js has been pushed by web APIs to the future. Because basically, if part of the core team spent like almost a year working on this, it means that they are pretty aware that there are things that needs to be reconciled back with React and the whole DOM itself. The next thing is scheduling. But before talking about scheduling in React, I want to just go through what schedule is like on the web. And basically, we as UI developers, we have to deal with some problems. First is that users expect immediate feedback, and we know that events can happen at any time, and we as developers can't predict those. So that's where schedulers come. So basically, those are like black boxes that are handy when we need to better organize resources that need to be shared, and basically those take some tasks as input and return uh, a list of priorities. And actually on the web, the resource that everything is fighting over is CPU time because it's usually for computation JavaScript code, updating GUI, and etc. And if you have tasks that are expensive, then the main thread stop working, as you know, and the result is bad user experience. But if somehow we can figure out how to split our code into smaller chunks that can be easily organized by scheduler, then we get better user experiences. So basically, that's what schedulers are. They provide a scalable solution to performance by letting us coordinate CPU and network bound updates, which results in improved perceived performance. And it's very important to highlight that those doesn't solve React.js problems, but scheduler solves UI problems. But schedulers in React. So React has got its own scheduler, and we always started about actually talking about scheduling in React when there was this whole concurrent React thing because it allows us to hand the rendering work to be paused and resumed later. And it does this by making tasks smaller, what they call fibers. And the scheduler itself as a package is basically, as the name suggests, a way to schedule work in the browser. And but it's unstable for now, so the API keeps changing and changing. But I think that the best thing um, is to show the schedule itself. So if you are interested in how fibers and the concurrent React thing work under the hood. Just this talk where I go a bit deeper about that. But the scheduler has 5 different priorities, which go from immediate to idle. And basically, they work like this. Immediate means do it now, and it really means now. What they call user blocking means do it now, but you have like a acceptable timeout of 250 milliseconds. And then you have normal and low priorities with 5 and 10 seconds. And then you have idle where you don't have timeout. And then this thing only happens if there's really if the browser is idle. So the difference is that the first one is really sync for those that mean now. But scheduler is a package can be found under the React Money repo. And I, if I were to show you how it works, I had a video here, but since we are online, I can just show you on my machine. So I have this simple web app for React for JavaScript of Fwdays 2020. And basically here I have a list of sessions, but I have all the sessions that they appear more than one time because I needed a huge list for this example. And the thing is that I can search sessions and it will try to highlight the sessions as I type. And you can see that the keyboard is, the keyboard events are not that responsive. And basically this happens because one, I have a huge list, and two, I keep doing some heavy computations when on the event handler. So what could be done to improve this? Basically, if I head here and change this flag to concurrent and schedule to true, you'll see some performance improvements. So here you can see concurrent and scheduled. And now as I type, I can type, okay, the experience is not, I don't have any downgrades downgrades to the experience, and the FPS keeps always like more than 50. So this is quite good. And basically, what was changed when I set that flag is that first I used React.unstable concurrent mode to enable what is called concurrent React, but this is not enough. I need to use the scheduler. So here I use what they call unstable next, but will be only next once the API is okay. And basically this is used for queuing a task with lower priority than the default priority of any interaction callback. So what I do is I wrap my unchanged handler inside this, making it lower prioritized. And also here have those functions which are send ping or send deferred ping, which basically marks some call to a analytics API because some for some reason it might be important to send a utilization API utilization data to an analytics API. But if you think those doesn't have to be sent at the moment, so we can defer them. And what I use here is the unstable schedule callback. And when we're using this function, we can just pass any priority from that list. In this case, I am using low priority. And then I have my function to actually send this analytics data. And here I am scheduling with lower priority. And what we noticed is that we went from this scenario where we have a bunch of those red dots signing that we have both issues in the event handlers to this scenario where all the components render okay and the analytics data is only sent when there's some idle time on the browser. So it was really a huge performance gain. And so yeah, we know that now that concurrent React can break long-running tasks into smaller chunks, and the scheduler allows you to prioritize which of those are important or less important. And talking a little bit about the web and scheduling, we kind of have a problem because in the web, everyone should use the same scheduler. So having more than one scheduler can end up in some resource fighting. For example, React could have its own scheduler, and React could have its own scheduler, then Angular its own, and then another framework its own, and there will be also the browser with its own. So those could be fighting each other. And then we need a unique solution. But then you might think, oh, we have some scheduling primitives already. Okay, we have set timeout, we have request animation frame, we have request idle callback, and we have post message. But the thing is that we need more standard scheduling primitives. Some of those are not reliable. And for example, there's a post by the Facebook engineers showing, for example, why request idle callbacks not 100% reliable, for example. So yes, we need some scheduling primitives, and and people have been working on this. There's an API called MainThread Scheduling, and you can find it on this link. But basically, it has been developed in cooperation of many important teams like React, Polymer, Ember, and the web standards community itself. But I would say that the whole work is mostly aligned with the work of the React core team. And once it's done, it will be integrated directly into the event loop. And here you can find a post, again, by Facebook Engineering, showing how they have been working with the browser APIs to make this whole thing, okay. And if I were to highlight parts of this API, I would mention is input pending, because basically what you have is, let's say that I have this while loop here, and I can then have navigator dot scheduling dot is input pending, and then I can stop doing some work if the browser is already busy handling some input event. And we could have even more elaborated examples. For example, I could detect what kinds of inputs are going on. So then I could have is input pending and then mouse down or key down or mouse up, key up, I don't know. And then we can really stop doing work if we will start receiving a bunch of events or something like this. So the conclusions I have on scheduling is that basically it's necessary for building responsive user interfaces, and we can solve this problem at the level of the framework with concurrent React and the scheduler. But a web standards proposal is in the making that's going to bring a good scheduling API to the browser. And on top of this, I also think that we can conclude that React.js has been pushing web APIs to the future. As you can see, the whole work on the web scheduler, it's been done aligned with Reacting and the React scheduler and etc. And then the next part would be control flow. So I was going to ask how many of you have heard of effect handlers before, but since we are not on stage, there's no this raise your hand thing. But for those who haven't, there's this post by Dan Abramov on algebraic effects and effect handlers and a bit of continuations. And I really like this post because it's very simple and it's very easy for people who are starting studying this. So this is the post. But the thing is, he provides this example where you have a function get name, and and it receives a user, and then if the username is new or not a valid thing, it needs to kind of ask the user. But here he uses some fictional JavaScript, which looks like try catch but with try handle, And here, instead of throw, we have perform, and perform will be responsible for performing a side effect. And instead of catch, we have handle, which is the effect handler to handle the ask name effect. And the most important thing I would say is this resume with, because it allows us to jump back to where the effect was originally performed. And on top of that, me and a friend of mine started working on a proposal to bring algebraic effects to JavaScript, and you can find it here. But this whole algebraic effect thing brings a lot of discussion, so I won't be focusing on this for now. But the thing is, when it comes to React, Sebastian Markbach, one of the guys behind the core team, he has been trying to bring those effect handlers and one-shot delimited continuations to JavaScript as a language. Has been like more than 4 years, as you can see in this discussion thread under the ECMAScript community. And also, the whole React team experimented with effect handler control structures for managing layouts back in 2016 as well. Again, they did the same when implementing the context API, but they end up not using those because, according to them, it was not compatible with their memoizing strategy. More recently, we have them working with effect handlers and hooks because, as Sebastian points, conceptually, hooks are algebraic effects. And you can see this discussion on the RFC for React hooks. And basically, I would say that the most intriguing thing that we have when talking about effect handlers and React isn't actually hooks or the work on context API or anything like this, but suspense. So if you ever try to see how a suspense compatible library works under the hood, you will see that basically what they do is that they throw promises, and a component is able to suspend the fiber that is running by throwing a promise, and this promise is caught and handled at framework level by React. And the thing is, if we get to see, we have this pretty much the throw handle resume pattern that we would have if we had effect handlers at language level. So basically, we see that in 2016 we had effect handlers as a proposal by Markbach, and also we had the team experimenting with effects for layout. And then on the next year, we have the experiment with effect handlers again, but for the context API. In 2018, we see effect handlers as React hooks, and most recently, we see they trying to mock effect handlers' behavior on suspense. And for me, what this timeline kind of shows is, again, React has been pushing web APIs to the future. And I think that there's some other cool stuff happening that are not directly related to those last 3 points. And the first one is trusted types. Basically, it's an API that is on the go for the web. It's not an e-React API. And basically, these APIs help you obliterate done as a text. So it allows you to lock down dangerous injection sinks. So basically, a security API, let's put it like this. And the thing is that in React.js, you also have this. So again, React is aligned with web APIs, and not only this, but for example, you have this pull request by Dan Abramov, where he kind of improves and implements the existing trusted types API on React. So for me, it shows the other part, which is React also pushes web APIs to the future. Also, we had something called fast refresh, which basically it's a re-implementation of the hot reload thing with full support from React, and it was originally shipped for React Native, but now the most of the implementation is actually platform agnostic, and the plan is to basically that you can use it across the board as a replacement for purely user-land solutions like Hot Reloader for React. And the thing is that adoption would require only integration with existing bundlers on the web, like Webpack, Percel, etc. And address this issue on how on where Dan Abramov explains how you could implement the fast refresh on your bundler. So again, this kind of shows for me that React keeps pushing the web APIs to the future because fast refresh is not a React thing; it's a thing that you can have on every framework if implemented on the bundle side. And there is also React Fresh, which is basically is a new generation of hot reloading, and it includes a bunch of stuff from scaffolding to infrastructure and some Babel plugin implementation. And basically, you first heard of this before in May when Dan Abramov shared this example. And basically, here he was showing like hot reload, what we would call hot reload, but in a sense that it was aware of state of hooks of like user state or the state changes caused by use effect, and it also was aware of changes on styles and everything. So this is what fresh would look like, and it all started with this PR back in May, where they set up initial scaffolding. But the thing is that you have a bunch of those APIs under the fresh umbrella, so you have really good progress on this. And you also have ReactFlight. And basically, Flight is an experimental API aiming to greatly improve server-side experience. That's what Philip Spice said. He's a guy on the React Dawn team. And then described it as a non-GraphQL solution for composing arbitrary data logic in a parallel hierarchy to your components. And by checking the discussions and the examples provided, what I get is that probably is somehow related to mapping URLs to data and views, similar to what you had on Navy, for example, but it's still unclear. And for me, the proof of how it isn't clear is that, for example, in the discussion thread, you have then asking Seb to explain the API a bit because it was still confused to him. So for me as well. But what I know is that there's some good stuff coming to both server-side rendering and mapping APIs to components. And again, you have a bunch of pull requests under the Flight umbrella, showing that you have a lot of work done on this. And a few conclusions I think we can have on top of this is that I don't know how many of you watching have already played with native UIs development, but for those who do, I would ask if you have heard of Component Kit or LIFO before. And basically, those are libraries by Facebook which try to mock the React experience of building declarative UIs for both native iOS with Objective-C and Swift and native Android with Java and Kotlin. And basically, last year, Apple announced what they call Swift UI, which is like component kit, but as a native API to iOS Next Code. And this was the big thing in the whole iOS community last year. So this takes me to the point where I think that React.js has been pushing other ecosystems to the future, and we have Swift UI and other declarative UI efforts on other platforms as a proof of this. And the second conclusion is that, again, I think that React.js has been pushing other web APIs to the future. And we have a bunch of examples of this, like the Scheduler API, the fast refresh thing, React Fresh, trusted types, and effect handlers. And last but not least, I think that React has been also pushed to the future by those APIs to show that it's still concise with the rest of the web and etc. So as example of this, we have Fire and Flare efforts, and again trusted types. And these three things led me to the tweet by Hosh, where he says React is such a good idea that we will spend the rest of the decade continuing to explore its implications and applications. And I wonder in maybe how many months or years this talk could go from the best is yet to come, the future of React, to the future is React. And there's one more thing. Um, Here I have this very, very small application only for demo purposes where I have a counter and few components, and I increment and decrement this counter, and that's it. And basically, there's something that puzzles me about this, which is the fact that whenever we change this counter, we end up walking this whole tree just to update one number in the component. And then you might say we have should component update, Mimo, use Mimo, pure component, component React, etc. But I see those as amortization for a crucial path issue. And this path issue is the fact that React is not reactive, as John Lindquist says in this tweet. And basically, again, this could be like a whole another talk. But the thing is that we have other solutions, as you know, and these three have a thing in common, like Elm and more recently Svelte. They are languages for describing reactive user interfaces. And basically, because those are really reactive, you don't have the issues that you would have the perf issues, and you don't need the perf amortization things that you would have need with React. So I wonder maybe that instead of the future is React, we could also have the future is not React. And there's one more thing, and to see the future, I also like to look back in the past. And this picture is basically me giving a talk about Ionic on an iOS developers meetup 5 years ago, telling them that Angular would be the future. And there are so many things that could go wrong here because it's Ionic and an iOS meetup and saying that Angular would be the future. So maybe a fourth conclusion would be don't trust my future predictions. This talk will be available under my speaker deck. And again, I am Matheus. You can find me on the web basically everywhere as White Combinator. And I'm a software engineer here at CRV. And that's it. Thank you for your attention. It ended up being a little too faster, but I cut down some things because it's live, but maybe we can discuss. That's it. Thank you, guys.
Thanks for your talk, Matheus. We've got some questions. We can start. Do you know when React team plan to release concurrent mode and other cool stuff like new HMR, etc.? Maybe new insider info from them? For example, they no longer working on React Flare.
Yes, so far I don't have any insight of the type of the flare like that they gave up on the whole thing for now, which is good. But to be honest, I don't know whether those like the whole concurrent React is gonna be stable. To be honest, I had the opportunity of pushing it to very small pet projects here in my company and push it with suspense for data fetching and all of those unstable things. Let's put like this. I had the opportunity to use those in small projects because they were small and experimental, and so far I've been getting good results. But to be honest, I don't have any insights on whether they will be real production ready. So, and I don't have insights from inside them. So most of what I have is discussions that I read, and so done. So I done. The future, I mean, hopefully it will be more stable. I would say that the thing that mostly people miss is that it will be more stable when it comes to, for example, server side handling and etc. But using it and also another thing that I would expect for it in the future is more and more libraries like SJabber from Zeit, which basically brings you a very good client data caching strategy out of the box with just few lines of code, and that is suspense ready. So what I would expect on the side of the community is that more libraries that take advantage of suspense, and maybe if someday JavaScript gets to have effective handlers, a whole rewrites of suspense maybe. But on React side, I would say just a more stable thing and support for server-side handling.
We've got one more questions while we were talking. Are you ready?
Okay, sure.
Great. Any component did catch error boundary, React Native hook for function components in the foreseeable future?
Sorry, could you repeat the question?
Yep. Any component did catch error boundary, React Native hooks for function components in the foreseeable future?
I admit I don't quite get the question, to be honest. Maybe someone from the audience could write it in other words. I don't know,
Oh, I think
but I'm not. It's not
if
clear. Maybe you're asking for a new life cycle method, or I
could you
don't know.
please clarify your question, Oleg? Just give us 1 minute. We will try to contact.
Sure, sure.
Um,
Or maybe he's
okay.
asking for a hook alternative for component with catch. Is it?
There
Or
is no error boundaries for function components at the moment.
oh, I get it. I get it. So I mean, I haven't seen any discussions regarding this. So maybe there are, but I haven't seen any discussions regarding this. So I would say no, but I would definitely check on the issues and pull requests, like literally searching for component digcat hook or something like this.
Okay, thank you very much for your talk then.
Thank you.